Welcome to the episode 1 of the Zephyr RTOS deep dive series. And let me say this upfront. If you are serious about the embedded system or the IoT development, you cannot ignore Zephyr anymore. This isn't just another RTOS. This is the platform reshaping how modern connected devices are built. What we are doing today, in this episode, we are cutting straight to the point. What Zephyr really is? No fluff, just the fact. Why global tech giant Intel, Nordic, ST, Google, Meta, and more are backing it with the real engineering resources. Why Zephyr is exploiting in the popularity compared to the legacy RTOSes, and where it stands in the fight against other solutions in the embedded ecosystem. Zephyr isn't an option anymore. It's becoming the default for secure, scalable, production-grade IoT. By the time we are done, you will have the crystal clear understanding of Zephyr architecture, its ecosystem, and exactly why it's dominating next gen device development. Get ready. So, buckle up, plug in your hardware, and get your environment ready. Because this series is all about learning the tool that real engineers are using right now. Let's stop talking about it. Let's dive in. What is an RTOS? Before we talk about the Zephyr, we need to rewind a bit and understand what an RTOS actually is. An RTOS, a real-time operating system, is built for one thing above everything else, such as deterministic, predictable timing. When something must happen exactly when it needs to, an RTOS makes sure it does. Now imagine a tiny microcontroller juggling multiple tasks at once, reading sensors, updating a display, sending data to cloud, handling interrupts, managing low power mode, and doing it all without falling behind. Try running all of that on bare metal code. It turns into the chaotic mess very quickly. That's where an RTOS step in. It brings order to chaos by scheduling tasks precisely, ensuring deadlines are never missed, providing timer, IPC mechanism, and hardware abstraction, and guaranteeing clean, structured execution every single time. RTOS means reliability plus timing plus structure. And because of that, you will find RTOSes powering everything from drone and wearable to industrial controller, smart appliances, and IoT devices. Why use an RTOS? So why not just write everything bare metal? Well, bare metal is fine when all you need is blinking LED or simple control loop. But the moment your device need multiple tasks, precise timing, communication stacks, low power efficiency, or networking, that clean bare metal code quickly turns into the tangle maze. That's where an RTOS come in. Modern embedded system don't run just one job. They read sensor, manage communication, handle user input, and take care of power management, all at the same time. And RTOS gives you clean, predictable multitasking to handle all of that. It also gives you reliability and timing guarantees. Critical tasks get CPU time exactly when they need it, without hack or timer jiggling. And with an RTOS, your code becomes more structured and reusable. That means easier scaling, cleaner maintenance, and smoother porting across different hardware platforms. In short, bare metal works for tiny project, but an RTOS is that lets you build professional grade embedded applications. And that's why almost every modern IoT and smart device relies on one. Think about portability. Moving bare metal code from an STM32 to an NRF52 is painful and requires rewriting drivers. In Zephyr, it's often just a configuration change. Zephyr at a glance. Now let's talk about Zephyr. Zephyr isn't just another RTOS. It's an open source, highly modular, lightweight platform development under the Linux Foundation with massive industry support. Companies like Intel, Nordic Semiconductor, NXP, ST Microelectronics, Google, and even Meta contributes to it regularly. Zephyr supports long-term release and almost every major hardware architecture: ARM, RISC-V, x86, ARC, and even Tensilica. It's modern, secure, scalable, and production ready. In fact, Zephyr is already running commercial products worldwide and continues to grow extremely fast. Key strength of Zephyr. So, why is Zephyr gaining so much popularity? It's extremely lightweight, suitable for very small MCUs. It's security focused, follow industry standard and best practices. It has a model build system built around CMAC and keyconfig. It supports a use library of driver and subsystems. And most importantly, its device model and configuration system make large projects easier to manage. Zephyr is powerful but also modular. You only include what you need. Architecture overview. If you look at the screen, you will see the high level architecture of the Zephyr RTOS. It is designed using the modular, layered approaches to ensure scalability and ease of maintenance. Let's walk through the stack from top to bottom. At the very top, we have the application layer. This is where user specific code lives. It contains the application, unique business logic. The key here is that this layer focuses entirely on functionality. It decides what the specific device needs to do without worrying about the low level implementation details. OS service and subsystems. Sitting directly below the application is the OS services and subsystem layer. This is a crucial part of the Zephyr architecture. This layer handles high-level modules like a networking, Bluetooth, USB, and file system. It provides feature-rich capability to application by utilizing the raw resources from the kernel below. Beneath the service sits the core kernel. Think of this as a traffic controller of the RTOS. It handles the essential heavy lifting, scheduling threads, managing memory, coordinating inter-process communication, and optimizing power consumption. It ensures the system behaves deterministically. Moving down, we have the hardware abstraction layer or HAL. This layer is critical for Zephyr portability. It acts as a universal translator, providing standard APIs for peripherals like a UART or SPI. This means if the underlying processor is swapped out, the application and the services code remains unchanged, only the HAL updates. And finally, at the foundation, we have the hardware layer itself. This represents the physical silicon, the SoCs, whether ARM, RISC-V or other, along with the actual sensor, LED, and communication modules that interacts with the real world. By separating this concern, specifically by placing heavy services above the lightweight kernels, Zephyr ensures that the ecosystem is robust, portable, and ready for the wide variety of the hardware platforms. Scheduler overview. The heart of any RTOS is the scheduler. Zephyr uses the priority-based preemptive scheduler. That means higher priority tasks will always interrupt lower priority ones, ensuring you meet real-time constraints. That meaning the highest priority task always run first, no exceptions. Need low latency? Use preemptive threads. Need cooperative task for power saving? Zephyr supports that too. This gives you flexibility depending on your timing requirement and power constraints. Hardware and the board support. One of the Zephyr's biggest strengths is its hardware support. Zephyr has one of the largest hardware support ecosystems. Each board is defined using the combination of device file and kconfig options. This makes driver easy to reuse and ensure consistent behavior across platforms. Zephyr supports popular platforms such as STM32, ESP32, NRF52, NXP RT series, Arduino, Raspberry Pi, RP2040, and many others. You can switch from one board to another with minimal code changes. Thanks to the device tree plus kconfig, porting between boards is incredibly smooth. Subsystems available. And this is where the Zephyr becomes a game changer. You get built-in subsystems for Bluetooth Low Energy, Wi-Fi on supported chipset, full TCP IP networking, file system, logging plus shell, sensor drivers, power management. With Zephyr, you are not hunting for third-party libraries. It's all tightly integrated and maintained. Let's compare Zephyr to the popular alternatives. Zephyr versus FreeRTOS. Zephyr is more modular, has strongly security, integrated, more subsystem by default, and uses the unified device module. Also, Zephyr has the more modern configuration system. Zephyr versus bare metal programming. Zephyr significantly speed up development, improves code organization, and make applications much more scalable. Overall, Zephyr is closer to the microkernel style operating system but optimized for embedded system. Think of it this way. Bare metal is bicycle, FreeRTOS is motorcycle, Zephyr is fully modern electric car, efficient, powerful and very well engineered. Here's what the typical Zephyr development workflow look like. First, install the Zephyr SDK. Then create the workspace folder. Build your project using CMake and Waste tool. Waste is the meta tool that manages the repository and trigger CMake. Once the compiled binaries are generated, then flash the compiled binary to your board. If required, then debug code using JDB, OpenOCD or Seeger tool. Zephyr integrated nicely with the VS Code and offer excellent documentation. Let's quickly look at the most basic Zephyr applications. Hello World. This simple example shows how minimal Zephyr applications are. Main function itself runs as a thread and you can print messages using print. We will go through more examples in the upcoming episodes. What coming next? In episode 2, we will set up the complete Zephyr environment. We will install Python, CMake, Ninja and the Zephyr SDK. We will also learn how to configure the toolchain for ARM and RISC-V. And of course, we will explore the Waste command line tool, the core of Zephyr workflow. Thanks for watching episode 1 of the Zephyr RTOS series. If you learned something new, hit like button. If you want more deep technical content, hit subscribe button and comments below which development boards you are using. I will include it in the future demos. See you in the next episode.